In this video lecture, we'll discuss the behavioral perspective on depression, or how we can apply learning theory to understand the development and maintenance of symptoms of depression. Our behavioral conceptualization reflects our knowledge that many episodes of depression are associated with stressful life events. Many depressive episodes have their onset in the context of an increase in stress. We also know that individuals who are experiencing depression may engage in behaviors that increase the frequency of potential stressors, and that this cycle can exacerbate symptoms of depression. So overall, when we are conceptualizing depression from a behaviorist standpoint, we are often considering it as resulting from a reduction in positive reinforcement. So we know that positive reinforcement increases the frequency of behaviors, and depression is characterized by a decrease in behavior. We can think about anhedonia. We see a decrease in behavior. We can see fatigue. People are engaging in fewer behaviors. So from a behaviorist conceptualization, when an individual is not experiencing positive reinforcement, the frequency of their behavior will decrease. When they're engaging in fewer behaviors, they have fewer opportunities for that positive reinforcement to occur, so their behavior will decrease further, and this cycle of operant conditioning contributes to that decrease in behavior and those other accompanying symptoms. An important concept to understand the behaviorist perspective is learned helplessness, and we can understand learned helplessness by understanding a key study in the development of this theory conducted by Seligman and Meyer in 1967. So this was a study that was conducted with dogs using a chamber that looked like this. So this chamber was constructed so that the floor was electrified and could administer an aversive shock. It was painful but not physically harmful. And the chamber was separated by a low wall that the dog could jump over. So in this study, there were two groups of dogs, and they were in yoked pairs, and I'll explain what that means in a second. So one group of dogs was in a group where the shock was controllable. So when these dogs went into the chamber and the electric floor was activated, the dog could terminate the shock by jumping over the hurdle. So these dogs relatively quickly learned that when the shock started, they would jump over the hurdle and the shock would be terminated. The other group of dogs was in the same kind of chamber, but the termination of the shock was not related to their behavior. Instead, this group of dogs was yoked to a dog in the first group, in the controllable shock group. So regardless of the behavior of the dog in the chamber in this second group, their shock did not terminate until the dog in the first box jumped over the hurdle to terminate the shock. So the dogs in the two groups experienced the same amount of aversive stimulus. So the length of time of the shock was exactly the same between the two groups because the timing of the shock was controlled by the behavior of the dog in the controllable shock group. However, the dogs in the uncontrollable shock group, their behavior did not influence whether or not the shock turned off. They only stopped getting shocked when the first dog figured out to jump over the hurdle. So in the first phase of the experiment, during the learning phase, you see what you would expect from an operant conditioning perspective. The dogs in the first group quickly learn to jump over the hurdle to escape the shock, and you don't see this behavior in the second group because their behavior is unrelated to the shock. However, the most important findings come from the second half of the study. In the second half of the study, all of the dogs were put into the chamber, but in this second half, all of the dogs could control the shock. So when they put the first group of dogs into the chamber, the dogs very quickly learned to engage in the behavior that would end the shock. So they continued to demonstrate learning new behaviors and acting in ways that would control their environment and eliminate the aversive stimulus. In contrast, the group of dogs that had received the uncontrollable shock at the beginning of the study, even though in this second half of the experiment they were able to terminate the shock by engaging in a behavior, they never learned that behavior. And in the videos, you can see that they look like what you might imagine dog depression to look like. So they are sitting in the corner of the chamber. They appear withdrawn. So despite the fact that in this second half of the study, that it would be possible for these dogs to engage in behavior that would decrease the presence of this aversive stimulus, they do not exhibit that behavior because of that previous experience of the uncontrollable shock. So this learned helplessness model has been applied to depression in humans by suggesting that individuals who experience uncontrollable aversive stressors, so negative life events that they are not able to control, decrease their behavior and are less likely to engage in behaviors that will help reduce stress in future situations, much like we saw with the dogs in the uncontrollable shock group. So this can contribute to that cycle of decreased behavior, leading to decreased opportunities for positive reinforcement, leading to increased experiences of stressors and aversive stimuli, like we saw with the dogs who were in the uncontrollable shock group, who later did not demonstrate an ability to learn to decrease that aversive experience, and contributing to that cycle of a reduction in positive reinforcement, leading to a reduction in behavior that leads to a subsequent reduction in further opportunities for positive reinforcement.